reasoning is a fundamental aspect of any AI program, and now we will look at the more important aspect of reasoning, namely inductive reasoning, which is a very important aspect of machine learning and other AI formalisms. The basic idea in inductive is that you go with inferring from a large collection of particular instances of truths to general rules which describe the behavior. So the basic idea is you are given lots of particular instances of specific kinds of behavior, and from that you infer a generic rule. When you say a generic rule, this is again tied to, as we discussed earlier in the AI context, is about what is the corresponding knowledge representation formalisms we are working with. So when you say logical knowledge representation, which is the underlying framework for capturing the knowledge and using for future, this one will govern what kind of a rule will form from observing a lot of particular instances. So, for example, let's take a very simple example. You suppose started observing, sun rising in the west today. Then tomorrow again you observe, then again, sun observed rising in the east, sun rises in the east tomorrow, day after, like that you keep on, suppose have 10,000 days, you observe that sun is rising in the east. So the idea is that it gives you a reasonable statistical and confidence that you can now form a generic rule saying that for any day you can say sunrise is in the east. So what it says is for any day sun will rise in the east for that day. So this means that having observed historical data of experience, we are trying to create a generic rule or knowledge which is concise, precise and general as compared to individual 10,000 pieces of particular instances of knowledge. So here is where machine learning comes in handy. Machine learning is precisely this art and the science of being able to abstract more specific, more general knowledge or piece of knowledge or formulation of the knowledge from lot of historical instances of past experience. So that is why you can say ML is probably the most popular form of inductive reasoning. And when I say inductive reasoning for ML, we are not always restricted to only finding out knowledge from history for just concisely representing the information present in the historical knowledge, but we want to use it for future. So I would like to be able to say tomorrow is going to rise in the east based on this universal law which I have gathered. Or I should be able to say in a month from now it will rise in the east. The idea is that when you are trying to gather generic rules from historical experience, it is to also allowing us to predict the behavior in the future. So that is the main goal of inductive approach to reasoning. So this is a very trivial example, but in terms of practical example, if you see, suppose you have a very special set of data which you observed from the laboratory of some specific scientific experiment. For example, you are saying that I am observing temperature every day, I am observing humidity every day, and I observe for 10,000 days. And then suppose I am able to come up with an equation which is saying that some constant times temperature plus C2 is a generic equation which is able to explain almost 10,000 combinations of temperature and humidity. So what have we obtained here? We have obtained here something like a weather condition prediction which is able to predict humidity from temperature, and you don't have to measure humidity always because you have the temperature data, and such kind of a predictive scenario is a very common use case for machine learning. To take a more practical scenario in a business context, let's suppose you have a lot of transactions which are being done with respect to, say, shopping, and you try to identify things like age of person who's buying. You try to identify what is the overall amount somebody is buying, and you have this combination of data over large thousands of records, and you may form a typical collection of rules saying that, okay, typically age greater than 60 people buy between 5,000 to 10,000 rupees per basket. Age less than 30 typically will buy less than 5,000 per basket. And then others will buy typically between 5,000 to 10,000. So now what we have is we have a collection of 3 rules which represent the truth which is contained in historical data of age and corresponding baskets of data which they have bought. And now this concise representation, which is a collection of 3 rules, saying that age greater than 60 will say they buy between 5,000 and 10,000. Sorry, like 10,000. Age less than 30 by less than 5,000, and age between 30 and 60 by between 5,000 to 10,000. Then what happens is this set of rules is the more concise representation of the repetition of thousands of records from the history. So there we're doing basically inductive reasoning and identifying a generic pattern as we would call it as machine learning, and now use this for a future when somebody is coming in, we look at his age and we'll guess what is his most likely buying habit by looking at what is the amount he's most likely to buy. Suppose he is somebody like 62 years, we'll say that he's most likely buying around 10,000 rupees. So the idea is that we want to use concise form of knowledge which is generic representation from huge number of particular historical pieces of knowledge. So we see how ML plays a very important role in inductive reasoning for generalizing the rules or hidden knowledge as contained in large collection of historical experiential knowledge. The form of knowledge, as I said, could be an equation like this, or it could be a rule written like this, or it could be a collection of rules like this. This is just some of the forms of knowledge present. There could be several other forms of generic knowledge representations which are concise representations of the overall representation of the knowledge contained in huge collection of small, narrow, particular instances. So that's why inductive reasoning is at the cornerstone of AI, and it's able to give the power of generalization because it can be used to predict the future behavior also.